Hello everyone, my name is Shaurya and I am an assistant professor at IIMT College of Management, Greater Noida. And my topic is remote sensing, and we will learn the types of remote sensing and its application. So now we are discuss what is remote sensing. Remote sensing is the process of detecting and monitoring the physical characters of an area by measuring. And remote sensing involves the collecting data about Earth's surface without direct physical contact, typically using satellites, aircraft, and drones. It utilizes various sensors to capture information such as electromagnetic radiations, including visible, infrared, and microwave wavelengths. Applications range from environmental monitoring and land use planning to management and agriculture. Remote sensing enables the analysis of large geographic area over time, the detection of changes and trends. Advancement in technology continue to enhance remote sensing capabilities, improving data resolution, accuracy, and accessibility for research and practical purpose. In recent years, with the progress and popularization of remote sensing technology, satellite imaging and aerial photography are becoming more and more advanced. We can get images which contain large amount of information. So here is a principle of remote sensing. Image processing techniques dividing an images into different categories using algorithms like supervised and unsupervised classifications. Comparing images taken the different time to identify change in land cover, vegetations, or other features. Sensors type their own signal and measure that return the detected natural radiations, combining data from different sources to improve the analysis and interpretation of the Earth features. So here the elements of remote sensing. There are these three types of elements of remote sensing. A platform to hold the instrumental and target or object. Third is an instrumental or sensors. There are the two types of remote sensing. First is passive remote sensing and second is active remote sensing. First, passive remote sensing relies on detecting natural energy that is reflected from the Earth's surface, and active remote sensing involves sending out energy and measuring its reflection back from the darkness. So here are the diagram of remote sensing. The remote sensing applications like agriculture, environment monitoring, urban planning, oceanography, remote sensing, health, forestry, climate changes studies, archaeology, etc. So, remote sensing applications here. Remote sensing has a wide range of applications across various fields, including agriculture. Agriculture crop monitoring, sensing soil health, identifying pests and disease, optimizing irrigation and fertilizer use. Second is environmental monitoring, assessing change in land use, monitoring, tracking natural disaster like wildfire and floods. Third one is urban planning. Urban planning is mapping urban monitoring, infrastructure development, assessing change in population density, and managing transportation network. Fourth is oceanography, monitoring coastal mapping coral reefs, studying ocean currents, and tracking marine pollutions. Fifth is archaeology, identify archaeological sites, mapping ancient landscape, and monitoring heritage sites of prevention. Next is remote sensing in health. Remote sensing in health like mapping disease vectors, monitoring the spread of disease, assessing environmental factors, public health. Forestry, monitoring forest health, assessing timber resources, detection, illegal logging activities, and planning conservation efforts. Here the disaster management, assessing damage after natural disaster, provide real-time information from emergency response and adding in planning. Next one is climate change studies. Climate change studies is monitoring changes in glacier sea ice and vegetation patterns, studying the impact of climate changes on ecosystem. Natural resources management, monitoring water quality, assessing mineral and energy resources, managing forest and wildlife habitats. Here are the classifications of land cover like first one is forest, second grassland, third wetlands, fourth agricultural land, fifth water bodies, sixth barren land, seventh urban areas. Classifications of land cover classifications categories the different type of land surface found on earth into several classes. These classifications typically include categories such as forest, forest areas dominated by trees and woody vegetation, grassland regions covered primarily by grass, herbs, and non-woody vegetations, wetland area where the soil and saturated with water such as marshes and bugs. Agricultural land areas used for farming, including cropland. Water bodies like lakes, rivers, streams, and oceans. Brand land areas with minimal or non-vegetation such as desert and rocky terrain. Urban areas develop land with building, rock, and other infrastructure. Here are the classifications of land use. First one is residential, second commercial, third industrial, agriculture, recreational, and institutional and open space. Classifications of land use like land use can be classified into various categories based on how the land in utilized. Some common classifications include residential. Residential land use for housing, including single family homes, apartments, and mobile home parks. Second one is commercial. Commercial land use for business such as offices, retail, stores, restaurants, hotel, and shopping centers. Third is industrial, like land use for manufacturing, warehousing, transportation, and other industrial activities. Next one is agriculture. Agricultural land use for farming and forestry, including crop and production, livestock raising. Next is recreation. Recreation land use for recreational purpose such as parks, playgrounds, sports field, golf course, etc. Institutional like land use for school, hospitals, government building, religions, institutions, and other public or private institutions. Difference between land cover and land use. So the reduction of precious and timely land use land cover LULC maps for monitoring human and physical environment is nowadays a matter of fact. They are used in multitude of different domains ranging from ecology, agriculture, mobility to health risk monitoring and management policies is by now a consolidated practice. Here the diagram of LULC, and there is the applications of land use classifications of remote sensing. Applications of land use classification remote sensing. Land use classify using remote sensing has applications across various fields including urban planning. Remote sensing can help identify land use pattern within urban areas, aiding in the planning and management of infrastructure, transportation system, and green space. Agriculture monitoring crops types, health, and changes in land use can optimize agriculture practice, improve crop prediction, and support framing techniques. Forestry management, remote sensing assists in mapping forest cover monitoring, assessing and managing natural resources. Environmental monitoring, like identified changes in the land use, can indicate ecosystem health, habitat loss, and the impact of human activities on natural landscape. Disaster management, remote sensing enables rapid assessment of disaster affected areas, adding in emergency response, damages assessment, and recovery planning. Water resources management, mapping land use help in monitoring water bodies, assessing water quality, and managing watersheds effectively. Infrastructure development, planning transportation networks, locating suitable sites for infrastructure projects, and assessing the impact of development on the environment are facilitated by land use classification from remote sensing data. Climate change studies monitoring land use changes over time contributes to understanding the effect of climate changes such as urban and agriculture. So here is the future trends in remote sensing. Satellites, smaller satellites with advanced sensors are making remote sensing more accessible and cost effective. Second one is big data and AI. The integration of machine learning and interpretation of large data set. Third is real-time monitoring. Advanced in communication technology are enabling near real-time data transmission, improving decision making in disaster response and environmental monitoring. Fourth one is integration with IoT. Combining remote sensing with the Internet of Things, IoT technology can enhance environmental monitoring and resourcing management. Here is the conclusion of remote sensing. Remote sensing is a powerful tool that involves the acquisition of data about the Earth's surface from distance, typically using satellite sensors. It provides valuable insights across various fields, include the environmental monitoring, agriculture, urban planning, and disaster management. Thank you for watching my YouTube lecture.